everyone. I'm going to talk to you today a little bit about Umbra and Penumbra for both the Earth and the Moon, how they're formed, why they're formed, and the amount of light that is in each of them. It can kind of be a confusing topic, so to make it a little bit more clear, I made a model here of the Sun, the Earth, and the Moon. Now, the first thing to understand is that the Sun, this giant ball of gas, is releasing light in all directions. So if we think of these strands of yarn as rays of light, it's these packets of photons moving in waves. They're moving and being released in all directions in straight lines. So it's releasing this way in a straight line, and this way in a straight line, and this way, and up and down, and in all directions in straight lines. And in the vacuum of space, it'll travel forever, unless it hits something. And we know that in our solar system, it hits planets, and it hits planet Earth. So we're just going to start by focusing on the light from the top and the bottom of the Sun. Now, that doesn't mean that there's no light from the middle part of the Sun. We'll just see that a little bit later. So light from the top of the Sun travels in all directions, and some of it, as it's being released in straight lines, it'll hit the top of the Earth, and some of it will hit the middle of the Earth, and some of it will hit the bottom of the Earth. And the same thing, light from the bottom of the Sun will travel in all directions, and some of it will hit the bottom of the Earth, and some of it will hit the top of the Earth, and some of it will hit the middle of the Earth. But you get this very unique shape, this kind of M shape. And this here shows the umbra, or the complete shadow of the Earth, and the penumbra. Both of these are the penumbra, which is the incomplete shadow. It's kind of a dim shadow. So why is this region here completely and totally dark while these regions aren't? Well, let's look at some of the other light that releases from the Sun. So we have some that releases from the top, and some that releases from the middle, and some that releases from the bottom. Well, anywhere in that umbra, regardless of whether it's from the top, the middle, or the bottom, if you try to put those rays of light in a straight line into this umbra region, right here is the umbra here. If I try to do it, you can see that it's blocked by the Earth. These hit the Earth, and they're not allowed to pass. So that light can't pass through, meaning that no light gets there, and this umbra is a dark shadow. Conversely, if you try to do the same thing in the penumbra, for example, here in this upper penumbra, what you'll see is these two rays of light hit the Earth, but this one here can travel in a straight line, enter the penumbra, and not be blocked by anything. Meaning, this could shine light on something in the penumbra. Meaning, the penumbra is not a complete shadow. The same thing happens down here. Just fix my umbra here. If I was to go down here, in this part, the lower penumbra, you can see these two rays of light hit the Earth, and this one here can travel unimpeded. It can shine in the umbra. Meaning, things in here can be hit by light, where things in the umbra can't be hit by light. They're in that shadow. So what does this mean in terms of an eclipse? Well, our moon moves around the Earth, it revolves around the Earth, and it can be in the penumbra, meaning some light will be blocked from hitting the moon, but some light won't. This one won't, these two will. This is a penumbral eclipse. It means that this dim shadow is on the moon, meaning the moon will dim. The moon can also be in the umbra. And when it's in the umbra, if any light tries to reach it, it can't, because the Earth is blocking it. And if it's in the umbra a little bit, it's a partial eclipse. So you get this dark shadow, and then you get a light piece. So this is the umbra and penumbra of the Earth. But the same thing can happen for the moon. So let's set this up again, but instead of focusing on the Earth, we're going to focus on the moon. Reset our light back here, and it's exactly the same the way that it forms. Light from the top of the sun hits the top of the moon. Light from the top of the sun hits the bottom of the moon. Light from the bottom of the sun hits the top of the moon. And light from the bottom of the sun hits the bottom of the moon. And we form, once again, the umbra here and the penumbra. What you might notice, however, is the umbra is actually considerably smaller than the Earth, meaning the umbra can't completely cover the Earth. And this little umbra, this region, is where the path of totality for a total solar eclipse is. So if you're in that region, that small umbra region, and you take all the other rays of light, and they're trying to come through this umbra, what you'll notice is that they're all completely and totally blocked by the moon. That's a total solar eclipse. But if you're in an area that's in the penumbra, only part of that light, see, this ray of light is not hitting the moon. Only part of it is hitting the moon, meaning you're in a partial solar eclipse. Once again, the reason an umbra forms is because in that umbra, all of the light from the sun is being blocked by the opaque moon. The penumbra, some of it is being blocked, but not all of it, right? Some of it is being blocked, but not all of it. So that's why you get an umbra and a penumbra and its impact on eclipses. I hope you learned something, and I hope this makes it a little bit more clear for you. Thank you.